Hi, everyone. Thank you for joining us today for Interactions for AR and VR Development. Before I introduce our speaker, I have a few quick things to go over. Please take a moment to read our code of conduct. We ask that you be kind and respectful to everyone, including our speaker. We want the reactor to be a place everyone feels welcome. Please ask questions using the live YouTube chat. Today's session was pre-recorded, but April is here live to take your questions at the end. In the chat, we'll also be sharing some links, as well as a link to our Reactor meetup page if you're interested in checking out what other sessions we have coming up. Today's session will be recorded and added to our Reactor YouTube page in about 24 to 48 hours. And finally, I will share a link to our Reactor survey. If you have a few minutes, we appreciate any feedback. I'm now going to start the session, and then I will bring April on at the end for questions.
Hello, everyone, and welcome to another episode of Journey into XR Development. My name is April Spate, and I lead our Spatial Computing Cloud Advocacy team here at Microsoft. I've partnered with the Mixed Reality team as well as the Microsoft Reactor to bring you all this 10-part series to help you get started with your XR development journey. If you've missed the prior episodes, no worry. We have all videos available on demand within the Microsoft Reactor YouTube channel. In addition, we also have a mixed reality playlist as part of the Microsoft Developer channel, and you can access that by going to aka.ms/mr-videos. Within that playlist, you'll also find additional videos for prior events that we've also held within our mixed reality world. Today, we're going to be exploring interactions for augmented reality and virtual reality development. Now, there's a variety of different ways you can interact with apps, and the one that you choose really depends on your app that you're creating as well as your audience and just how realistic you want those interactions to be. So here I have an example of a woman using a HoloLens. She's moving things around in her theater scene with her hands. Look at how she's moving that moon right there. That's pretty cool. So we categorize interactions across two different input models. The first one's going to be near input model, and that's going to be interacting with anything in your virtual environment at a close distance. So for example, if I happen to have a hologram that's about 12 inches away from me, so about a foot, that's going to be something that's going to be near. I should be able to grab something of that nature with my hands. The next one is going to be our far input model. So with our far input model, that's going to be interacting with objects that are going to be at a distance. So anything, let's say, for example, if it's 10 feet away from me, naturally, I'm not going to be able to grab that with my hands. However, there are ways to interact with those objects depending on the corresponding input model that you're using, so that way you can have those interactions. So that's where you have that difference between how we interact with objects in real life as opposed to something that you can do either in augmented reality or virtual reality. You will want to be mindful of whether you do near or far inputs. Again, it's going to depend on what sort of realism you want to have in your object. So if we have an example of doctors learning how to operate on an operating table, you likely wouldn't have the ability for them to grab things off in a distance that they may need for the operation because that's not going to be realistic. However, if you have a video game where you are capturing aliens or shooting aliens, for example, you should be able to interact with that at a distance because you'll need to have the projectiles go at a far distance. So again, it's really going to be dependent on your use case that you are using for your project. One thing to keep in mind as I am sharing these different interactions is that not every interaction that I'm going to share is going to be available across all devices. There are definitely device limitations or interaction limitations across devices, and that's just given the way that these different devices are created. So while there may be some interactions that's available for a HoloLens, for example, that may differ if you happen to be using smart glasses or if you happen to be using a VR headset. We will be exploring some examples across various different devices that you can use for XR development, but I do have some examples again that may not be supported across the device that you may be using. So do keep that in mind. And it's also something to think about as well as you are deciding on what sort of devices the user should be able to try your experience. Because if you want to enable something like eye tracking and it's not supported within your device, that's going to be a hindrance of the ability to add that feature to your app. So we have our categorization of near input versus far input. And now with regards to our input models, we have three different categories. One's going to be hands and motion controllers. The next is going to be hands-free. And then the final is going to be gaze and commit. We're going to explore each option, and then I also have some examples for you to view here so you can get an idea of what that's actually like in execution. Okay, so first up, we have hands and motion controllers. So within that, we have three different modalities. The first is going to be direct manipulation with hands. The next is point and commit with hands. And then the final is going to be motion controllers. So the first one up is going to be direct manipulation with hands. It's a near input model, and that's going to be the ability to use your hands to move, grab, scale, rotate, what have you, virtual objects with your actual hands. This sort of model is going to be instinctive since it's what we are used to doing in the real world. It's how we anticipate or expect to interact with objects in the real world. And so with that said, it's going to be very user-friendly. It poses a very low learning curve because as people are trying out these XR experiences and they're able to interact with their hands, it feels very natural to them. It's not going to be something that's going to be outside of the norm. And so therefore, if you are aiming for an experience that should more or less mimic real life in terms of interactions, direct manipulations with hand is going to be your ideal sort of interaction. Do keep in mind though, this isn't something that you can do with all devices again. So therefore, you want to ensure that your device provides this. Whether you're going to be utilizing direct manipulation with hands in augmented reality or virtual reality, I think it's a really great option. It's actually the one that I prefer to use most. Just again, it gives that more natural expectation of how one would interact with an object. So let's take a look at an example with the HoloLens. So here's an example with the HoloLens. You can grab objects and scale them. You can rotate scenes around as well. And then also you can use solvers to command objects near you. Now this use case is very interesting in the medical world. We have some medical professionals. They're using their hands to view what's inside of this human body, and they can select objects or human body parts and view them. Here we have an example of someone doing something with smart glasses in augmented reality. So she is using her hands to select whatever it is that she's viewing through these smart glasses as well. So again, doing button presses and such, it's really pretty much like you would expect to do in the real world if you were to interact with something on a screen, but instead now it's going to be virtual. So the next one we have is going to be point and commit with hands. And so this far input model is going to enable you to place objects really anywhere in the distance. And then you can point and do some sort of a commit, whether that's going to be a pinching motion, and that will indicate that you've selected that object. What we tend to suggest doing is adding some sort of a hand ray, because that's going to enable the user to know pretty much where their hand is going to be pointing. Now, rather than have that hand ray extend from the fingertip, we actually have ours for the HoloLens extend from the palm of the hand instead, because if you happen to be doing some other sort of commit with the fingertips, like a finger pinch, you don't want that hand ray to be confused with the pinching motion. So therefore, having that ray extend from the palm is going to be a better option. And here we have an example of someone in virtual reality. So they are pointing with their hand, and you might not see him do it too well, but he is committing with that controller that's in his hand. He presses down every so often, there he goes, to commit. So that's an example of point and commit with hands, but in VR. Next up, we have motion controllers. So this is going to be both a far and near input model. With motion controllers, you're going to be able to do all of your interactions with a controller of some sort. That sort of controller is definitely going to vary across devices, depending on what sort of device you're using. So for example, for VR, usually there's some sort of controllers that come with the device where there's buttons you can push. There's a trigger as well that you can press as well. If you're doing something for a gaming console that also has a VR version that's available, or it supports VR games, you may be using the actual game controller as well. Regardless of the device that is doing the actual rendering of the 3D scene, there are options to map different hardware or different controllers, so that way you don't have to necessarily use the standard controllers that come with the devices. Now, yes, that will definitely vary across device, but there is that option. This is also going to be really great for the use of adaptive controllers. And so adaptive controllers, it's going to address the needs of those with a disability, and you will enable more users to be able to actually try out your app or use your app. And so that's a really good thing to be cognizant of as you are creating your apps. So here I have an example of a guy that's in virtual reality, and within his hands are two motion controllers. And so as he's moving around, he's able to select whatever it is that he's selecting. And these controls are also just keeping track of where he is in this real world space. Another form to consider is him using this bike to also control his movement in the virtual world. So the next input model we have is going to be hands-free, and within those we have two modalities. One is going to be voice input and the other is going to be gaze and dwell. Hands-free is going to be great for those scenarios where your users aren't going to be able to use their hands, and therefore they need another way to interact with the virtual environment. So first up is going to be voice input. It's my second sort of interaction to integrate into my apps, just given that I'm a really big fan of using speech within AR and VR. So voice input is going to be a far and near input model, and you're going to be able to use that to manipulate or interact with objects, whether you're close or if you're going to be at a distance from those objects. With voice input, the user says an utterance of some sort, and from that, it's going to trigger some sort of action in the app. So if I wanted to say blast off, that may trigger a rocket to blast off in my scene. Now, the thing with voice input is that you do want to account for accents. We all pronounce things in different manners, whether that be culturally, geographically, regionally. So therefore, we want to ensure that if you are using voice input into your apps, do test it out with users across various different accents, just to make sure that the app is picking up or understanding what is being said across these different sort of accents. You can also make sure that you are accounting for different languages. So if your native language happens to be English, for example, you can think about those users who may speak another language, such as Mandarin, or someone who may speak Japanese. In addition to that, you also want to avoid using system keywords. So if your device supports voice input and one of the keywords is quit, which quits an actual application, you don't want to have that keyword used as one of the keywords in your app, because that will conflict with things and it can throw some stuff off, and it can also quit the app if you're using quit, for example. So here, let's take a look at an example that I've used with the HoloLens. Okay, so here we have it. This one is actually going to be one of my more favorite, because it just really helps identify just the power that you can have with eye tracking. So as I am looking around at the different objects, when my eye focuses on one, it starts to rotate. And you might not be able to see it too well, but there is just a slight faint little circle that is used as the cursor to help me indicate where my eyes happen to be looking. So there's two things that can happen with this one, as I mentioned. One, you say one command, which is select, and then the other one is explode, and that's going to blow up the object. So let's try that out. Explode. Explode. There we go. Explode. Oops. Explode. And you may have noticed that at first initially didn't. That's because I looked over to the side and then I said it. So focusing on the object is going to be really important. Here's another. Select. And again, there's two different options that you can do, whether it's select or explode. The next one we have is going to be gaze and dwell. So gaze and dwell is going to be both a far and near input as well. Essentially, you're going to do a gaze either with your head or with your eyes, and dwelling is going to be the duration in which you are focused in that direction. So this is going to be ideal for loud environments. So if you're not able to use voice because there's just a lot happening around you, being able to do gaze and dwell is going to be a good alternative for that. So for eye gaze, it is going to require that your device supports eye tracking. Otherwise, you won't be able to track where the user's eye is. And for head gaze, that's going to be tracking the direction of the headset that you're wearing. So let's take a look at an example with some eye tracking. All right, so this next example is going to be for auto eye scroll. What's going to happen is that it's going to keep track of where my eyes are. As I start to look down, the text is, or the scroll bar, if you will, is going to start moving the text down. There's a faint circle that's keeping track of where my eyes are, and that's what's helping determine where the scroll bar should start scrolling down. So it's pretty cool, continuing to look and read without having to actually go and touch that scroll bar. And then if I look up, it will start to go the opposite direction and move up. The next interaction model that I have is gaze and commit, and this is going to be the final one that we're going to explore today. So for gaze and commit, the first modality is going to be head gaze and commit, and then the second is going to be eye gaze and commit. How do these differ from gaze and dwell? So for gaze and dwell, I mentioned that yes, you're doing a gaze either with your head or your eyes. However, you're dwelling, which means that you're going to be focusing on a certain object for X amount of time. Whereas with gaze and commit, what's happening instead is that you are gazing either with your head or your eyes, but you're going to follow up that commit with another sort of action, whether that's going to be a voice command or a gesture, or if you have a motion controller, that might be pressing a button on the controller. So that's going to be the difference between the two. So let's explore what that actually looks like more so in practice. So the first one being head gaze and commit, also a far and near input modality. And so this is going to be best for gross targeting. So much larger targets that are going to be exponentially large. If you recall the example that I shared earlier with the woman in the theater, she is targeting very large objects. She moved an entire mountain as well as an entire moon. And so that's going to be those larger targets. And that's going to be when head gaze is going to be perfect. Also, you're going to typically pair this with either a gesture or a voice command. And so gestures are going to vary by devices. That might be a finger pinch, for example, that would be a gesture. And so therefore you would do your gaze with your head and then you'll use your finger to follow up. As for a voice command, you could, depending on the direction of your headset, wherever that is gazing towards or pointed towards, you'll follow up that with a voice command such as move, for example. And then next there's going to be eye gaze and commit. So also a far and near input modality. This one you'll typically want to pair that with either a hand gesture, a voice, or controller. And it's also helpful to provide subtle feedback for your users so that way they know where their eye happens to be looking. And so whether that's going to be putting some sort of like a highlighted glow around the object so that way the user knows that yes, my eyes are locked into this particular object. I do have an example as we think about eye gaze and commit. One way to think about it is with augmented reality for mobile phones. So your mobile phone is essentially going to be where your eye is actually focused. So here we have an example of a woman viewing laptops on her phone. Once it's in view, she's able to commit with her finger by swiping to view another device. So this is going to be an example of target selection and positioning. And here I have some cubes in my scene. I can use my eyes and voice to move them around. So what I'll need to do is two things. One, I need to look at one of the boxes and say, put this, and then I follow up and say over here when I look somewhere else. So let's start with this cube. Let's see, put this over here. Put this over here. And there we go. So it's been moved. Sometimes when you're doing things with voice, it does take a little bit of really getting into the groove of understanding how to say things certain ways, if you will. It can be a challenge, but in any case, you can always try again like I just did. So for the second one, I can use my eyes and hands. So what's going to happen with this one is that I can select one of these cubes with a pinching motion to select, and then I can look somewhere else and it's going to give me a preview of roughly how it's going to appear there. So let's start with this cube. Let me go ahead and select it. I'm going to look over to my right, and there we go. So let's try it again with one a little bit more visible because I went from yellow to yellow. Let's see. Select this blue one. I'm going to look over here to the purple and drop it. And so I wasn't sure if maybe you could see that or not, but if I select this yellow again, if I look over here, it does give you like a little preview. So that's going to be more that you can do with your eyes. So when it comes to adding interactions to your XR experiences, the great news is that you don't have to start from scratch. There are various toolkits and SDKs available, and today I have 4 listed here to share with you all. The first one is going to be the Mixed Reality Toolkit. The next one is the Oculus Interaction SDK. That's still in beta, so as a FYI, depending on when you're tuning in to check this out, but as of today, it is definitely within beta. Then there's also the Virtual Reality Toolkit, and that's going to be great for VR experiences. And then there's also the Unity XR Interaction Toolkit, and that's going to be great for whether you're doing AR or VR. With the Mixed Reality Toolkit, you can also utilize that for VR as well. So that wraps up the different sort of interactions that you can integrate into your AR and VR apps. Again, be sure to check what your device supports as it relates to these various interactions, as not all interactions are supported across all devices. If you're interested in tuning in for upcoming episodes, be sure to check out meetup.com. This is where we place all upcoming episodes for our Journey into XR Development series. Again, if you missed any prior episodes, they are available on demand at the Microsoft Reactor YouTube channel. You can also access those within the Microsoft Developer YouTube channel in our Mixed Reality playlist, which you can access by going to aka.ms/mr-videos. Thank you all again for tuning in, and happy creating. Hello, everyone. Thanks again for joining. And so I am April, for those who don't know me, and I'm excited to be here with you all because I love talking about a lot of the intro things that folks should know if they're getting started. So I am checking out the comments now. If you have any questions, do place them into the chat for the platform that you're in, and I will answer them. So far, though, I am just seeing one, and that's from Nicholas. And the question is there a matrix of devices and manipulation models? So, in a perfect world, there would be such a matrix. However, there are so many devices available that people can use to create different experiences. So, unfortunately, I'm not aware of such a matrix that may exist that can give you an idea of what features are and aren't available. However, within Unity, there is a way, and I would say to search through their documentation for input, but there is a way in Unity to um, to query the capabilities of a device. And so that I have seen, but in terms of a full matrix, haven't seen anything necessarily. And if there is something like that that exists out there, please someone do share it. I'm sure there'll be some very happy people out there. For some of the more I would say if you're, I wouldn't even say it's from the more popular devices, but if you happen to have a certain device that you're interested in using and you want to know if it's capable of doing something, definitely check out the user document or the documentation for that specific device, the developer documentation specifically. And in there, it should let you know what the device can and can't do. So hopefully that's at least a start if you're interested in implementing something. So Matt has a question. Could you please recommend developer-friendly device kits for Unity, AR, MR capable to use for prototyping and ideation? So just to make sure I'm answering this question, when you say device kits, is that like an actual device itself? If that's the case, then I would say mobile would be a decent option, whether you have an Android or an iOS phone. The reason being is that, for one, typically, most people already have a okay, perfect, as your question. Um, so typically people have a smartphone already, and so that's like the hassle is having a device. The next part then is learning how to create for it. So if you have the device, oh, you want glasses. So let me finish with mobile devices, and then I'll talk about glasses. If you have a mobile device, then because that's just half the battle there, from there, it's just a matter of referring to the platform for your phone and learning more about how you can develop for it. If you have an Android device, you're good to go on Windows or on Mac. If you have an iPhone, then you can do your programming on Windows, but you'll need to deploy it on a Mac because you'll need to use Xcode, and then likely you'll need a cord to connect the phone to your computer. As for glasses, if you're doing anything with augmented reality, I would say developer friendly is going to be quite the relative term, because for me personally, I've used between the HoloLens, I've used the Magic Leap 1, and I currently use the Oculus Quest for my VR development, and I found them all to be approachable. For context, I started working in this space in 2019, and my first device I had was a Magic Leap 1, for example, and I found it um, relatively good to use. So it depends on, I guess, the person, I would say, more so, but those are the 3 that I've used, and I found them to be good, suggestions, but that doesn't mean anything outside of those 3 isn't good. It's just that those are the only 3 that I've personally used. So there's a question from Peter: Does HoloLens work with WebXR-based content for interactions? And so you can use, WebXR, for sure, for your interactions. And I'm not sure if much more I can answer that question, but you can. I don't have anything to point towards you per se in terms of getting started, though, unfortunately. Let's see, any other questions? And Nicholas has asked, have I tried the Magic Leap 2? Unfortunately, I have not tried the Magic Leap 2. The devices that I've mentioned are the only ones that I've had a chance to ever try. And let's see. Yeah, for Matt, with regards to finding a price that's going to be price, a device that's more accessible in terms of price point, it is going to require a bit of homework to look into how much devices currently are. The ones that I listed are just the ones that I tend to use, but that doesn't mean they're the only devices that are out there. So if anyone else is tuning in, if you're aware of a device that you're using for AR or VR development that is budget friendly, then please share with Matt to give some more insight there. Let's see, any other questions? Oh, and then also just did want to say about glasses. There's also like the in real light as well. I have tried that out more so from a end user perspective rather than me creating for it. So probably not the best to suggest whether in terms of the developer experience, but I have used that before at least. Um, so another question from Matt: Are there relevant standards slash protocols that would suggest as an MVP? If you can elaborate on that, so I can hopefully better answer that question. Are you referring to for the app that you're creating itself, or any standards around just adding in interactions and what you should be mindful of? Because if that's what you're inquiring, we do have full documentation on different interaction models, as well as best practices and guidance and do's and don'ts. It would have taken me longer to to mention that in this video. But if you're searching for glasses, so I would say, based on glasses, relevant standards and protocols, I don't have anything that comes to mind necessarily. Um, Hopefully someone else in the chat does too, though they have something to suggest. So apologies, I'm not able to answer that question for you. Okay, so suggestions for hardware requirements, able to be debugged live. Okay, I see what you're saying now. I would say personally, if you're able to try things out without having to deploy it to the device, that's always super helpful. That can be a limitation sometimes, since that happens to be one thing you mentioned. That happens to be one thing that I find to be a challenge, because some devices you have to deploy in order to test things out, and then every time you make a change, you have to keep doing it. Whereas some others, if you're in Unity, you can just press play and it shows up in the device, and then that helps a lot. So I think having that is super helpful without having the need to do the deployment. Another thing that I would think about, might be minor for you, but it does become time consuming though, as at least with your initial startup, is just seeing how much needs to be downloaded and installed just to get started. I haven't necessarily found a device that's perfect with that respect, but I do like to take the lesser of evils. And so as you're looking into what sort of like engine you want to use and whatever platform you're developing for, take a look at all of the specs that are necessary for your computer, for your operating system, for your graphics, and so on and so forth. That's going to make a big difference as well, because the worst thing that you can do is to get a device and you're ready to start doing development, and then you realize your computer is not spec'd to par for what you need. And so I've run into that as well, and that's not it's not a fun experience, I would say. Oh, I'm having that. My sound's a little scratchy. Is it okay now? Can someone confirm? Can someone confirm if it's better? I'm going to keep talking. If it still sounds bad, okay. I might not have anything that immediately know me to fix my audio. Okay, it still sounds robotic. Give me a second, everyone. Dion, if you can take me off camera for a moment, I need to go.
Thank you, everyone. We're going to give April a minute to get her sound and audio fixed. So thank you all for your patience. While she is doing that, I will share a couple links here in the chat. We have a link to an I Want MR if you want to find out more about mixed reality and what's going on in that space. You can do that there. So I just shared that link in the chat. And then, as I mentioned in the beginning, we do have a survey. So if you have a few minutes and you can fill out the survey, that would be great. So let me put that in the chat. I don't think we can hear you.
Oh, I was on mute. That would explain.
There we go.
Okay.
Perfect.
All right, so this should be better, hopefully, for everyone. In terms of requirements, the other thing I would say is just be mindful of battery life as well. That can definitely ruin some fun if you're trying things out and then the device doesn't stay on for as long as you're hoping. Trying to think if there's anything else I would say. Yeah, that's something I haven't really thought about too much. So that's why there's nothing that's coming to mind necessarily. But those are just some of the things I would say to keep in mind as you're looking for, you're checking out devices. And I guess also check to see how often updates are being made to improve the device as well, because it's at least nice to see that there are improvements being made over time so that the device features don't just pretty much stay as they are. Most of these devices in this space, there are always new features being added every so often, but I would just say just to check to see what that frequency may be like, and checking their product roadmap too to see if there's anything that's coming down the pipeline that's worth knowing as well. So hopefully, Matt, that answered your question. And okay, so there is a question from Daryl. Does eye tracking use the battery or processing power more than hand gestures? That is a good question. And I am not sure of the two which one it uses most. I would say in order for it to do eye tracking, it will use your device's camera at least. So that I'm not 100% sure whether one consumes more power than the other. And you're welcome, Matt. Yes, so Jeff has asked, I mentioned documentation on adding interactions. Where can we find those documents? So I am going to provide that link for the folks at the Reactor to paste. I'm gonna go on mute real quick so you don't have to hear my computer typing. Give me 1 second. All right, so in our Mixed Reality documentation, we have some documentation around interactions and a lot also with UX. I would suggest checking that out if you are getting started. So Dion, if you can provide that to the people in the chat for me, please. Check that out. Within that interaction section, there's a full breakdown of the models that I mentioned today. And then as you start to get more into like the hands-free and the eye-based, we get a bit more in depth with regards to just some considerations to think about as you're implementing these things. And so with some devices or some platforms or some engines, if you will, depending on the SDKs that you're using, there's not much to do in terms of adding the interactions outside of maybe like adding a component, for example, to an object. So like in Unity, because I tend to use Mixed Reality Toolkit, for example, for us, we just add the object manipulator script. And then from there, you're able to just start touching, grabbing holograms. So it's no additional coding. Likewise, if you're doing something with like, even if you were doing it in like, I can't even talk right now, for like VR as well, it's the same thing. Some of the toolkits that I shared at the very end of the video, that's pretty much how a lot of the setup is. Once you have the package imported, it's usually you're adding something to a component, and then it gives you that sort of ability to interact. For things like the eye tracking, for example, it's a matter of checking a couple of the boxes here and there. So there's instructions on how to go about doing that for sure for HoloLens. If you're looking at other devices as well, that's why I always say check out the developer documentation, because it will take you through the steps to go ahead and implement it or integrate it. And so that would be my suggestions around that. Okay, let's see. All right, is there any other questions from anyone? And I feel like there's something outside coming through. There's someone screaming. I think that might be it then for questions. So thank you all for joining us today. Next week, we will be, or at least I'll be sharing Babylon.js with you all. So for anyone that's interested in doing things on the web, instead, we'll be taking a look at the Babylon.js playground, and we'll be doing some coding with JavaScript. So if you are someone out there who knows JavaScript or has an interest in JavaScript, then Babylon.js may be of interest to you. And so I will be sharing what you can do in there as well. And thank you, Nicholas. Happy Easter from my bunny chair. I definitely appreciate that. But until next time, thank you, everyone. And I hope you enjoy the rest of your Tuesday.
Thanks, April.